This lesson is the same type of thing we did in 7.2. Remember in 7.2 we had problems where we had exponents. 4 raised to the x is equal to 16, and we had to get those both to be the same base, and then we set the exponents equal to each other. That's the first thing we did in the last lesson. The second thing we did in the last lesson was putting things from log form to exponent form and vice versa. Today, we're going to start out with doing both of those in one problem. The exponent form, we're going to solve that by getting the same base. So again, if you want an exponent sheet, I've got plenty of those. I will give you one on the test. Obviously, on the quiz, you can use it so you can have that. So let's do this first one. Now, again, I got to put these three steps. Do this up here. Maybe I should have put in step format like I usually do. But I think for the most part, I think you're going to pick up on it pretty quickly. The biggest thing is solving like we did in the last section. So this equals x. Now you don't actually have to do that. The only thing is when you put it in exponent form, if you don't have a placeholder for that, it's really kind of hard to look at and kind of hard to like think about. So set it equal to x, and then we're going to change this to exponent form. Now hopefully you guys remember this. If not, look at your notes, watch the video from the last lesson. But in exponent form, your base number is your base of your exponent. Your answer, what it's equal to, is your exponent, and this one is equal to that 64. So we have 4 raised to x is equal to 64. Like we did before, I want to get those bases to be the same. Now, most of the time, not all the time, but most of the time, whatever that smaller number is, that's going to be the base you use. So I'm going to try to see if it is 64. Can I make that into 4 raised to some exponent? So use your exponent sheet, trial and error. 4 raised to 164 is 64 on this list over here. And remember, it does continue on forever and ever. The 64 is right here. So 4 to the third is 64. So what we did is we said that was 4x. We changed 64 to 4 to the third. And we set the exponents equal to each other. Personally, I'm going to start doing this. But if you want to skip this step right here, I'm okay with that. Because we just looked it up on our list, and we saw that 64 was 4 to the third. But obviously, the x has to be 3. Have to do it that way, but I think that's not a bad idea. Then number 2, same type of thing. We're going to set this equal to x. So we have 9 raised to the x is equal to 243. Now the problem with this one, and we did problems like this the other day, is if you look at that 9, there's 243 on here. So I cannot change 243 into 9 raised to an exponent. I can't do that. There is not that option. So instead, you have to change both of your bases. Now again, on the ones on the quiz or the test like this, I tried to make sure they were ones that were ones you were familiar with. So for instance, I didn't use 32, where you have to know 32 is 2 to the 5th or something like that. I use ones like 9, where you guys know 9 is 3 squared. So I changed 9 to 3 squared. That's the only option for 9. Now that I know that 9 has to have a base of 3 because there's only one, that's the only option, then see if 3. So 3, so you 243, so it's right here. So I know 3 to the 5th is 243. So I can change that to 3 to the 5th. So now when you solve that, that's 3 raised to the 2x is equal to 3 to the 5th. Now the bases are the same. Again, remember you multiply your exponents together. So 2 times x here. So we end up with 2x is equal to 5. Once your bases are the same, you set the exponents equal. Then you go ahead and solve. So this one is x is equal to, and if you want to leave it as a fraction, you can. I couldn't care less. I think that's easier first. Now again, I didn't have a lot of these examples because we just did this in the last lesson. I guess I should say this way. In my opinion, the hard part of this is what we already did in the last lesson. Because setting it equal to x and putting in exponent form, I don't think is too bad. That solving part, I think that is difficult, but we've done several of those last lesson. Any questions so far? Okay, number 3, I'm going to erase some of this. I'm going to do some things over here. You do not need to write this down, what I'm about to show you. It does not have anything to do with the actual problem in number 3. There is a theorem, and I'm not really going to get into it too much, but if you have something like, we just had 3, let's do, if 3 to the third, 3 to the third is 27. There's a theorem that if you take 3 to the negative 3, that 27 turns into a 1 over 27. So if you have a negative exponent, really what you're doing is, but really you're going to take out whatever you have, whatever 3 to the third is, so there's nothing left in the numerator, which means there's got to be a 1. And that's why you end up getting 1 over 27. I think you can also think about it as taking the reciprocal. You definitely can in this lesson. I was just trying to think about mathematically. So same thing if we have like 4 squared is 16. That means 4 to the negative second is 1 over 16. Now going to number 3. So that means 2 raised to the x is equal to 1 over 8. It's a fraction. Hopefully you know, or you can think that it's probably going to be a negative. So again, I always ask myself, what would be 2 raised to what number is equal to 8? Well, that's got to be 3. Well, if that's 3, then 1/8, the answer's got to be negative 3. That's one of those problems that a lot of people make it a lot harder than it is. And again, it's super easy, but once you get the hang of it, or once it clicks, then it should be. Don't have fractions. But again, you're just asking yourself, 2 raised to what number is positive 8, then you're taking the negative of that, and that's going to give you that 1 over 8. Any questions over that? I think I explained it better in my 8th period class. I had 3 or 4 people that wanted me to stop and re-explain that, which is perfect. I'm glad they did. So is everybody good with that one? Because you can look at your x 2 to the third is 8, but 2 times 2 times 2 is equal to positive 8. 2 times 2 is 4, 4 times 2 is 8. Does that make sense? All right, go ahead and do those problems on your own. All right, my answers are up there. Again, for number 4, once you know 125 is 5 to the third, if you just want to skip and put x equals 3, and that's probably how I would do it, because again, you're asking yourself, 5 raised to what number is 125? So once you find 125 to the third power. I will say number 5, if you change 16 into 2 to the 4th, I believe, you can also change 64 into 2 to the like 6th or 2 to the 8th or something like that. I don't remember exactly which one. But you could, for number 5, you could use a base of 2 as well. Number with 1 over 81. So 3 raised to what number is positive 81? That's 3 to the 4th. And so 1 over, your answer is negative 4. You don't actually have to show this step down here that I put if you don't want to. I just like to put that especially on your notes so you know 3 to the 4th is 81. So 3 to the negative 4 is 1 over 81. Lastly, number 7, make sure you're putting that as log base 10. Remember, if there's not a base number in there, it's got to be 10. So make sure you don't actually have to put the 10 in this spot here if you don't want to write that out. But I would highly encourage it until we get used to logs. Any questions on those before we move on? All right, so we're going to come back to problems like this at the end. We're going to shift gears a little bit, and now we're going to talk about simplifying logarithms. And the good news is we're simplifying these very similar to what we do with exponents. So for instance, the exponents have a product property where if they have the same base and you multiply, that means you can add your exponents together. We're going to kind of work that way from backwards, where if we're adding these together and they have the same base, we can multiply them. So again, I know these look like they're different properties, but it's because they're written in a different order. Here said b raised to the m plus n, into multiplication, that's what we're doing here, essentially. And I think a big reason is because logarithms are inverses of exponentials, and that's why they kind of do them the other way around a lot. So if you're adding those together and they have the same base, you're multiplying. So I'm actually going to, where it says in your own words at the top, I'm going to write same base, because for at least those first two, they both have to have the same base. And that's not, I mean, it says it in the formula, but it's not specifically stated. And then I don't know a good way to write in here besides, I would say when you add, and then I put an arrow, multiply. And I know that maybe doesn't make a lot of sense until you look at what I'm talking about. As you can imagine, then there's similarly a quotient property where if you are dividing, that means you are subtracting your exponents, which again, the inverse of that. If you are subtracting your logarithms, that means we're dividing. So again, I would put subtract and divide. And then I will also add on this one, order matters. For multiplication, the order doesn't matter very much, but for quotients, for division, it definitely does. And it helps because it makes sense. Whatever the first thing that's listed, that goes as the numerator. So log base m, that means m is here, and then is in the denominator. Then the last one, and we'll actually use these a couple different ways. Today, we're just going to make it where if you are multiplying by a number on your log, you can take that number and put it up as an exponent. We're actually going to do the same exact formula, except for backwards. Solving exponentials using logarithms. But for today, if there's a number in front that you're multiplying, we're going to move that up as an exponent. So questions like this will say, simplify as a single logarithm. So I want these to be simplified, and I want to be written as a single logarithm. So for number 7, again, don't make these harder than they are. They both have the same base. So it's adding, so that means we multiply. So this answer is log base 7 of 18. Honestly, if you didn't show your work, put log base 7 of 18, I can give you credit for that, because there's not a lot of work that you couldn't do in your head. Then the next one, number 8, you're multiplying 6 by that, so that 6 moves up as an exponent. So it's log base 3 of x to the 6th. A property. And the last one, I did give you this hint. Make sure you're doing the exponents first, and then combine using that, making that adding into a multiplication. So this 5 moves up as an exponent. This 3 moves up as an exponent. So that's log of x raised to the 5th. If you want to put that they're base 10, you can do that because they don't specifically say that. And log of x to the raised to the 3rd. So we've done this property before, but when you have an exponent raised to an exponent, we know we can multiply. So that's x to the 6th. Now we finally have it simplified enough that we can move on to the next step, where if it's adding, we can make that into multiplying. So log base 10 of x to the 5th multiplied by x to the 6th. Again, we've done this exponent property before. When you're multiplying those exponents together, when you're multiplying together, you add your exponents. So this ends up being log base 10 of x to the 11th. Log of x to the 11th. Any questions on those so far? So the next one we have is going to be doing all of this stuff. We're going to simplify it into a single logarithm, and then we're going to use that logarithm to evaluate. Subtraction, so we're going to divide. Log base 2 of 160 over 5, which is the same thing as log base 2 of 32. that, but now we're going to evaluate that. So that's going to be equal to x. That means 2 raised to the x is equal to 32. That's right here. That's 2. 2 to the 5th is 32. Number 11, same thing. You're adding those together, which means we need to multiply. Which means we need to take 27 multiplied by 8. So log base 6 of 27 times 8. Again, you can skip that step if you want to. That's fine. It's 216. So set that equal to x. Six raised to what number is 216? Again, you do trial and error, or you can use your list. So 216 is right here. That is 6 to the 3rd. So x is equal to 3. Are there any? Go ahead and do the next two on your own. Number 12 gets not like the worst thing ever. Used. Wait a second. We'll put these answers up here in a bit. All right, my answer up there. So those last two, number 12, it throws off a lot of people. But remember, 7 to the first power is 7. Putting in here, raised to the x is equal to 1. To the 0 power is 1. Putting on the test with that, but just something interesting to remember, I guess. Number 13 is a little bit more involved. Make sure you make that 2. This 2 into an exponent first and simplify that out. That gives you 4. Log base 4 is 64 plus log base 4 is 4. Then you can, since you're adding, you can multiply. 64 times 4 is 256. And then you can set those equal to x and solve. Any questions on these at all? All right. If you have any questions, feel free to ask.